Hello class, and congratulations on completing Unit 1, Intro to Functions. Today we're starting Unit 2, which is dealing with some algebra, so we're shifting gears completely. You might want to organize your notes such that you put all your Unit 1 stuff together, or put a title page in letting you know it's Unit 2, just so that when you get ready for your final exam you are organized. So taking a look, here we are 2.1, and we're adding and subtracting polynomials. So for our warm-ups for 2.1, what we need to do, ladies and gentlemen, is just go over some terminology to make sure that we are up to speed on terminology. So the first description we're going to take a look at is, what is a term? Okay, a term is a product of a number and variable with an exponent. Okay, so that's the term. And terms are separated by adding and subtracting signs. I can get rid of that for now. Okay, so adding and subtracting signs separate them. Let's take a look at this example for specific. I'll just try and get my highlighter up. Maybe hopefully my highlighter will work here. If I can get a highlighter. What color do you want today, guys? Let's go teal. So taking a look at this example, 5x minus 3, we classify it as a binomial. It's a binomial because it has two terms, and the two terms are 5x and negative 3. Those two terms could get broken down, so 5x is the variable term because it has the variable, and negative 3 is the constant term. It stays the same. We could never change negative 3. So that's why it's called the constant term. Note also, ladies and gentlemen, that the 5x can be broken down even further, where 5 is the coefficient or the numerical coefficient. It's the number in front of the variable, and x itself is the variable. That's quite often what we sub in or to solve for. All right, next one, ladies and gentlemen, we're going to take a look at a polynomial. Okay, a polynomial is an expression with one or more terms. Exponents are whole numbers and coefficients are real numbers. All right, next thing we're going to take a look at is a coefficient, which we just reviewed up here. Okay, the coefficient is a number by which a variable is multiplied, or in front of is another way of taking a look. So the coefficient in negative 4y is negative 4. Last, we take a look at a constant. A constant is a term with no variables. So in the above example, remember that the negative 3 is the constant term. Why do we call it a constant term? Because no matter what we sub in for our independent variable, that part will never change. Okay? We could sub in x equals 0, x equals 1, 2, 3. This value will change, but this will always stay constant. That's why we call it constant. All right, let's see how we are in our review of adding and subtracting polynomials, ladies and gentlemen. All right, so the first thing we're going to do is simplify. Remember, ladies and gentlemen, when we go to simplify, notice here we've got a trinomial, adding a binomial, and subtracting a trinomial. And what we need to do is look at the sign in front of each bracket that tells us what we need to do. So for the first trinomial, ladies and gentlemen, there's a positive sign out here, even though there's nothing there. So what does that mean? We're going to multiply everything by a positive imaginary 1. So we just drop the brackets. Looking at the binomial, the second term, which is the second bracket, my fault, out in front is a positive sign. So we're going to just write that down. And here's where we got to be careful. The third one, ladies and gentlemen, notice here there's a subtract sign. So what does that mean? We got to times everything in this bracket, or think of your distributive law, by negative 1. Or just change the sign. So it's going to be negative 4x squared minus 2x and plus 3. I find that people will make the first one negative or change the sign of the first one but forget the second and third. So just be aware of that. After we have the brackets removed, then we can collect like terms, ladies and gentlemen. And to collect like terms, we start with the highest power first. So just take a look at x squareds. We got 2x squared plus 1 more x squared. That's 3x squared minus 4x squared. That's going to give us negative x squared. Okay. Taking a look at our x terms, we've got negative 7x and minus 2 more x's, ladies and gentlemen. That's going to give us negative 9x. Okay, and taking a look at our constants, ladies and gentlemen, when we have plus 6 minus 9, that's minus 3, add 3, they actually cancel each other out, so we don't have that as a final term. All right. We should remember that hopefully from grade 9. Okay, if not from grade 10. Now we're going to take it a little step further and we're going to talk about equivalent expressions or equivalent functions. Easy thing to do, ladies and gentlemen, is to simplify to the same expression, then they are equivalent. Okay, so for example, if you've got one equation that's in standard form and one equation that's in vertex form, you take the vertex and convert it to standard and you get the same equation, then you know that those are equivalent functions. All right, let's take a look at this example too. Okay, are this expression and this expression equivalent? Well, the first thing we're going to do is break things down and break each expression down and do it separately and then see if they're the same. So for the first one, when we simplify through, we're going to have negative 2b plus 3a for the first expression. And remember, a negative times a negative becomes a positive. So for the second bracket, we've got plus 3a and minus 2b. Collecting like terms, how many a's do we have altogether? 6a. How many b's do we have altogether? Minus 4b. Let's see what we get on the other side, ladies and gentlemen. So for the second expression, I'll just change colors so you can have it color-coded. We're going to have 4b plus 10a, subtract 8b, and subtract 4a. Okay, collecting like terms, how many a's do we have, ladies and gentlemen? We have 6 a's. And how many b's do we have? Minus 4b. Okay, so the question we can now answer, are these equivalent? And we are going to say, yeah, yes, these are equivalent. And you could say because both simplify to 6a minus 4b. Good. All right. Example 3. Are f at x, this expression here, and g at x, this expression here, equivalent fractions? Okay, so what do we need to do is think about it. What form of a quadratic are these in, ladies and gentlemen? And you should realize that they're in standard form, although they're not in correct order. Let's just put them in correct order. Okay, so I'm going to go f at x equals 5x squared plus 13x minus 4. Okay, and the second g at x, so it's g at x equals 3x squared minus 6x, and sorry, my fault, subtract 11. So taking a look, ladies and gentlemen, what do we know here? We got to think about it. Well, if we are in standard form, what do we know standard form gives us? So when we think about it, the graph, we're going to think about the y-intercept. Okay, are they the same? Okay. And we're also going to think about the shape of the parabola, i.e. is A the same? Because they both have to be the same. If functions are equivalent, ladies and gentlemen, on the graph, they're going to be exactly in the same spot. So we know already that the y-intercept is the c value, and looking at these expressions, are they the same? No. So that's one way to prove it. Other way is shape of the parabola. We know we take a look at A for the shape, because that tells us our step pattern. And even that, the one is going to have a stretch of 5 and the other one's going to have a stretch of 3. So we can already prove that. However, we need to show that they are not equivalent. To show they're not equivalent, ladies and gentlemen, we're going to choose a value like x equals a. And remember, guys, a is any number. And I would choose an easy number. Sorry, number. Which doesn't look right. So we're going to let a is a number. Okay? And show that they don't equal. So in this case, ladies and gentlemen, let's just take an easy one and let's let x equal 1. So we're going to substitute wherever we see an x, use function notation. So we're going to have f at 1, and we're going to sub that in. Okay, so you can go to the original format or you can go to the rearranged format. I'm going to stick with the original one because that's the original question that was given. Because we go 13 times 1 minus 4 plus 5 times 1 squared. Okay, so simplify that. 13 times 1 is 13 minus 4 and plus 5. Okay, so what do we get there? We plug that in our calculator. We get 14. Let's try it for the g at x. Okay, so for g at x, we're going to replace wherever we see an x, we're going to put a 1. So g at 1. So subbing that in, it's going to be 3 times 1. Oh, sorry, I'll do the original question. Let me erase that. Sorry. Oops. One of many yet to come this season. Okay, so negative 6 times 1 plus 3 times 1 squared and minus 11. Sorry about going down on a hill there, but running out of space. All right, so simplify that. You're going to have negative 6 plus 3 minus 11, and this equals negative 14. So what does this prove? You say since f at 1 does not equal, now that's the, just let me back up here, ladies and gentlemen. You're going to see this sign a lot in this course. So this is equals, okay, and to change it means does not. It puts a cross through it. Okay, just like think of a non-smoking sign, right? Okay, so f at 1 does not equal g at 1. Therefore, these functions are not equivalent. All right, cool. Any questions there, ladies and gentlemen? Okay, the first thing I want to do is, before, I know we've got the homework assigned here, I just want to do 13 together because it's kind of hard. Okay, so for your homework on number 13, when it talks about having a graph, let's just go over what they look like. Can they be determined or not? So with the first expression, ladies and gentlemen, after you've read the problem, okay, if you're given point 2 and something else, okay, so say that point exists. For example, it could exist on a parabola, and it could exist on a straight line. So there's not enough information to tell you. So this is where you cannot or can't be determined. Okay, let's take a look at B. Again, B gives us 2 values. So you could, for example, on a grid, if you got 3 and 4, say you've got 2 values here. Maybe this is your parabola coming up here, and then maybe this is your, maybe you've got a line coming down here. Okay, so again, this cannot be determined. Okay. For C, ladies and gentlemen, you've got this expression. For example, if I put 8 down here and I put 2 dots here, ladies and gentlemen, this is an example where it's not equivalent. Okay. For D, ladies and gentlemen, just do it here. If you've got 5 being up here and 7 being down here, this cannot be determined either. And again, it'll make more sense once you've read the question. Okay. And E. So for E, ladies and gentlemen, let's say we have 2 quadrilaterals. So say we've got one right here. And pretend that this is exactly the same. I'm going to try to do my best. Put it right over top of it. Oopsie. Imagine it being right over top of it. It's just my smartboard, ladies and gentlemen. Okay, so if I have 2 quads, okay, then this is equivalent. Okay. Hopefully that's helpful, because I know that's a tricky question. Again, come see me in class if you need some help with that. All right, here's your homework, ladies and gentlemen. We've just done 13, so you're doing page 88, numbers 2, 3, 6, give 9 a try, 11, 12, and there is 13. Have a fabulous day, guys. See you later.